All right. This may be review for some of you, but if you have not done this before, time value of money, this is just to get you up to speed. But I think you probably covered this at least in accounting, but just in case not, I just wanted to put this out there. So um, basically, I'm just going to show you how to do time value of money calculations using a formula. I'm going to show you how to do it on a BA2 plus calculator. I recommend learning how to use that calculator if at all possible, because if you ever want to sit for professional exams, they normally have a no programmable calculator rule. And so knowing how to do it on a non-programmable calculator, like a financial calculator where the formulas are built in, is really valuable for exams like CPA and CMA and things like that. So, so we're going to do that. And I'm also going to talk about it in Excel, because wherever you work, you will have Excel. So some of the definitions that we're going to use, the first two I want to talk about are present value and future value. So present value is the value at t equals 0, and the future value is the value at some later point, right? And so normally we think of present value as today, you know, and you may hear me say that, you know, discount it back to today, but because that's normally what we're trying to do is say, okay, well, in today's dollars, what is this future cash flow worth? So, and so we're going to be dealing with present value and future value. But then we're also going to need to talk about the interest rate, because that's one of those two are different, right? There's going to be some period of time that this will grow. And so we need to understand what that interest rate would be. You're going to hear me call it the discount rate, because it's normally what we refer to this as, is how we're discounting back to the present present day. But if we're talking about this for a company that's looking at maybe investing their resources into a project, and this could be the same as the cost of capital. You know, we'll do weighted average cost of capital later, and we'll get into that a little more detail. The opportunity cost of capital, because you could take that capital and invest it somewhere else. So we have to think about what else that could be doing. Required return. When we talk about investors, we normally, you know, we'll talk about required return, because they're not as interested in day-to-day operations and that sort of thing. It's really more, are you getting me what I think is reasonable given the level of risk that I've taken on as an investor? So, so taking these together, oftentimes what you'll see, I know this is virtual, not face to face, but I normally would draw this on a board. These call them railroad tracks, where you have the time period across the top, right? And then you'd have whatever cash flows. Present value would be here, and then future value is wherever, you know, we end up taking this for. So, so this is just to show. Then these cash flows here would be any periodic cash flows. So you could have, for instance, a bond that's paying a dividend every or coupon every 6 months. And so I would have those coupon payments, and then at some future date, I would get the par value. And this is to show, like, if you had if you're going to get $100 at the end of year 2, then this is how we would write that. We would take this $100 and we would need to discount it to period 1 and then all the way back to period 0. The discount rate we're going to use for that is that R. And so to put this into a mathematical formula, this is without any periodic cash flow. So this is just some lump sum going from, you know, some present value and then growing, right? So if you notice here, this relationship, we're just going to multiply the PV times 1 plus R. You'll see 1 plus rates used a lot in finance. And then you'll just take that, raise it to a number of power, where that number is equal to the number of periods, right? So that's going to allow us to do that. You could rewrite this and say future value divided by 1 plus R to the T, you know, to do the discount. It's the same formula. So you're gonna see this formula an awful lot. And this is just to give you an example. So if you have you're going to invest $100 for a year at 10%. What will that end up being? And you've done these types of calculations where it's, $110 because you're going to get that 10% on the 100. But what if we go for that second year? Well, it would be, another 10% growth. And instead of being 120, it's actually going to be 121, right? Because we get interest on our interest, right? So this is what we refer to as compound interest. So simple interest is really one of those things that we just talk about as a thing that exists, but we normally do not use it in financial transactions. Instead, we use compound interest, and all of the calculations that we're going to be doing will be compound interest. So the formula that we're using, things like that, that's all compound interest. But compound interest, will be easy to understand as we go through these problems. So you can see the difference here, the future value of simple interest compared to compound interest. And so obviously we're getting interest on our interest, and this is why we put our money in investments, because we're wanting it to grow, right? And so the ability to get interest on your interest obviously allows it to grow faster. Now, just take a little aside to tell you about the BA2 Plus. Understand I don't get anything from Texas Instruments. I just use their calculator because it's the one that I learned a long time ago, and it does everything that I need, and it's not programmable, so we can use them on professional exams. So the Texas Instruments is going to have a financial function built into it so that you can put in a present value, a future value, an interest rate, and a number of periods, and it will tell you what periodic payment you would need, for instance. So, so we have the ability to solve these problems as we're going through it. One thing though is as we work these, like I'm showing you this one where present value and future value, one of them have to be negative. And you may be thinking, wait, we just did it. They were both positive. The present value was $100 and the future value was $121, so shouldn't they both be positive? You have to remember on the calculator, we're going to use the sign to show the direction of cash flow, right? So if I'm going to invest $100, I'm going to pay $100 now into the investment, and then I'm going to receive 121 in the future. So it's an outflow of money initially, and then it's an inflow of money in 2 years. And that's why we have those signs, right? So it's to tell you the direction of cash flow. When you have periodic payments, those signs become much more important because we could have years where sometimes we make money, sometimes we lose money. And this allows us to show that the cash flow could be coming in or going out. The IY button that you'll see is the R. The reason they say IY really just goes back to sort of a historical thing. It's just like interest per year. So they could, of course, called it R, but I've seen it as IY so much is kind of where I think about it. And then PMT is going to be 0. Later on, I'm going to show you how to do this with other payments. So. And then I'm showing a couple of slides here for you. These are like those standard slides that I show. I'm just going to give you a few seconds, and then you can pause it if you need. But this is just to help you in case you're getting an issue. This tells you basically how to go and reset the things in your calculator, right? So yeah, that's really why I'm just showing this to you, so you can pause it if you need to come back and look at this. So so let's get back into doing some problems here. So the $100 that we had before, what if you did it for 5 years? And you can do this by hand if you want to, just to see what happens with it. But you can also put this in the calculator. So if you here's doing it using the formula, we get 161.05. If you put this on the BA2 Plus, you would say N for the number of periods is 5. Your interest rate is 10%. You put it in as 10 because they assume you mean percent. So don't put 0.10 for 10%. The present value, negative 100. Again, remember, if I'm paying, it's negative. If I'm going to receive, it's positive. There's no payment. So then you would hit compute future value and you'll get that 16105. So it works the exact same way. And in fact, that's why it works, right? It has to, we have to get the same answer or that there would be an issue. So you can do the same thing in Excel. Excel has FV as a function for future value computation. PV is the function for present value. Rate is for that interest rate, which it will give you as a decimal. So this is where, you know, the calculator assumes that you mean percent for that interest rate, but in Excel, everything's decimal. So you're going to need to remember that when you calculate that. And then NPER is the number of periods. So the N previously is NPER here. So, but yeah, so Excel has this built in as well. Again, it's good to know that as well. And this is just to show how you would do the same type of calculation. If you notice again here on Excel, it's bright red to jump out at you. We don't put 5.5 for 5.5%. We have to move the decimal 2 places, right? Again, this is just one of those little things that's Excel's a little bit different, but it's because Excel is thinking to pure math. It's not thinking finance. So so we just have to make that adjustment. This right here, just a way for you to practice doing some of these. So I'll have a few of these problems. I won't walk through all of them because it's really more about you trying to practice it on the calculator or Excel. But I'll have these here, then you can pause it and then try to type it in and make sure you're getting the same answer. Okay. So a couple of things about the future value for you to keep in mind is this relationship. So if T gets bigger and bigger, then I'm going to expect future value to get bigger, right? Because I'm multiplying by a bigger number, right? And so even if R remains the same, if T increases, future value increases. Okay. Also, if T stays the same and R goes up, this whole thing will go up. So future value goes up, right? So if interest rates go up, we grow faster. If we have more time, we grow to a higher number. So, so that's a bit about present value. As far as future value or present value, so often these calculations, when we do these as problems, it goes down to, you know, how much do I need to save today to pay for this in the future? Or I'm going to receive something in the future. So how much should I pay for that today? Right. And so it's just to get everything back because we know if I'm going to receive $100 in 2050, it's not worth $100 today. Right. And so that's when we do these present value calculations. For the present values themselves, the present value is what we would receive today. Right. And the reason it's going to be discounted could be lots of different reasons. One's the opportunity cost. I could take the money and put it somewhere else. And then the other thing that we'll talk about a lot is the risk and uncertainty, because in finance, we talk a lot about the risk exposures that we have. And so it's better oftentimes to have it today than to have it some point in the future. And then again, the same type of calculation, but remember, we've got those cash flows in between. Those are the payments in between are going to be zero for us right now, but we'll introduce some later. So we've had this conversation a few slides ago, but it's just here as a refresher. So here's doing those same types of calculations that we were doing before with future value. Showing how you would do this on the calculator and how you would do this in Excel, right? And again, remember with Excel, we always have to put the rate in as a decimal. So make sure you move it 2 decimal places over. This is using a single period, right? So it's the T equals 1. We can do this also for multiple periods, right? And so this is, you know, your daughter was just born and you want to save up for 17 years. You know, how much do you need to put aside now to have that, right? So, and this is just to show you how to works with a formula, and then you can do the calculator and Excel to practice those. And as another practice, here's another one. Give you a time period, an interest rate, and a future value, and then just compute what the present value would be for that. So as we were looking before, you know, if T goes up, right, and so this denominator would get bigger, so that if you're dividing by a bigger and bigger number, then this must be going down, right? Because it's going to have the opposite effect. And you can see that if T were to be constant and R were to increase, again, you're dividing by a bigger and bigger number. And so we would see that happen again. So, and this is often, again, this is how I would write this on the board. You know, we would take this like future value, and then I would just draw an arrow back and say, what is the present value if it's this amount in the future? And so you can do this for multiple periods. And in fact, that's often what we do, right? So you can see how we can have periodic payments in between, but we're not quite to that point yet. Oh, I'm sorry, I'd already mentioned this. So if R increases, the same thing happens that we saw when time increased. So if you're discounting at a larger rate, or if you're discounting it over more time, then the present value will just continue to get smaller. All right. And then this is just to show how if the interest rate were to change, right? So if the interest rate goes up, you notice that this number is smaller. I know it's negative, so you'd say, no, the negative, you know, but if you take the absolute value, right? So in this case, I pay $248. In this case, I pay $310, right? So the discount rate makes the present value, absolute value of the present value smaller. Okay, so again, remember present value is future value divided by that 1 plus R to the T, right? And remember, if one of these is positive, the other one will be negative when we're doing the calculator, or if we're doing Excel, because it's going to give us that direction of cash flow. And so we can do the same type of algebra that we did before, right? Take present value and divide both sides, right? So then it's future value divided by present value. Right, so 1 plus R to the T is that. You take the T root of both sides, right, and then you subtract the 1, right? So I know this looks a little clunky to do, but again, that's why I'm also teaching you how to do this in Excel, and also how to do this in on the calculator, right? So it's a lot easier there because you're not taking you know, like 12th roots or 20th roots or anything, because, you know, obviously time can be longer than 5 years. But with the calculator and then with the with Excel, it's just as straightforward as anything else. And then this is doing the same type of calculation. You know, just another problem again for you to practice using both the calculator and using Excel. And then here's another practice one for you using the calculator and using Excel. So it's just good to practice this, you know, because the faster you can do it, obviously, the easier it is for you. As far as solving for the number of periods, again, we can rearrange terms, you know, to do the math. And I know it does not look pretty, but I'm not going to ever expect you to do the formula there. Instead, you have the calculator that you can just compute what's missing. And then also Excel has NPER for number of periods. So you can get it that way. But if you're wanting to do an example for practice, here's one for you. You know, they give you what your future value is going to be. You know, you're going to pay $20,000. You have 15,000. You want to grow it at 10% a year. How many years will it take? Right. And you see there, no matter the calculator or Excel, you're going to get the same answer. Again, you should always get the same answer. And then if you were just curious how that looks, you see it's like 3.02. If you did that using the formula, it should. Okay. Oh, I skipped over it. Sorry. Using the formula, you see this would end up being 3.02. So we would still get there. But yeah, it's obviously much easier to use the calculator. So, but yeah, that was just a refresher, hopefully, on time value of money. If not, it was your first time seeing it, but hopefully it was very straightforward. If you do have any questions, please, again, always just email me. I'll be very happy to answer anything that you have. Thank you.